Good morning, everyone.
Good morning, Andrea. Good morning, everyone.
Good morning, Massimo. Thank you for participating in this new GMI webinar. We are a little bit late, 1 minute late. Sorry for this, but also we are waiting other people coming. I see that other people connecting. So if you wait for just 1 minute and then we start with this new webinar. Today the topic is will be safety relays, and with Massimo together we discuss about the topic, which is why safety relays for, let's say, safety applications. Because relays, I'm pretty sure that you are using a lot of relays in your application, but maybe not for SIF, and when you are applying for a SIF application, then the things is completely different. Okay, so I don't see any other person connecting, so Massimo, we can start. So
Okay, thank you, and good morning again to everyone, and thank you for your participation in this GM International webinar dedicated to safety relay and their application. Hello and welcome also to my colleague Andrea Spolo. Ciao Andrea, who will help me to lead this webinar. Well, today's topic intends to provide a general overview into the world of SIL certified safety relay, always widely used in the process automation application. A little explanation on how our meeting will take place today. Our webinar will be mainly divided into two parts. A first part dedicated to a short presentation where Andrea will introduce the main concept related to safety relay and their application. The second part will be left free for your question on the topic, in which Andrea and I will try to give an answer. Well, I kindly ask you to use a question and answer function for your question and not the chat of Zoom. Thank you. Before starting with our presentation, let me introduce in short myself and my colleague. As already mentioned, I have a pleasure to having with me today Mr. Andrea Spolo, our Global Manager Account. Andrea has over 20 years of experience in the machine and automation market. He has great expertise in international relations in the automation sector and has consolidated his experience in Europe. Now he takes care of customers and markets worldwide. I'm Massimo Pagani, Product Manager and Technical Support at GM International. I have been employed at GM International for about 8 years, and my main role is to receive and process customer technical requests or assist them in the correct choice of product to be used in their application. Furthermore, I collaborate with our research and development department for the implementation of new devices to be put on the market, and with the sales and marketing offices to promote GM products worldwide. So before Andrea starts with his presentation, I would like to introduce my company. GM International was born from the experience of Elcon Instruments, and for over 25 years designed, engineers and produced a complete range of SIL certifying safe devices. Our products are used in automation packages such as DCS, ESD, fire and gas, marine, and so on, in several industrial sectors as oil and gas, petrochemical, pharmaceutical, food and beverage, and railway. The next slide shows the complete range of our products. Here we can see intrinsically safe barriers, safety relays, which we will present shortly, isolators, multiplexers, SIL3 power supply, termination boards dedicated to the most popular PLC DCS system, are multiplexer, and so on. In addition, our company promotes advanced courses of functional safety conducted by an expert trainer such as Tino Van de Capelle. You can find all the information about it on our website. The goal of our company is to provide and guarantee innovative and high-quality products. All our products are tested one by one and must comply with the strictest work specification. Our products are ATES and SIL3 systematic compatibility certified by third party. Furthermore, over 15% of GM employees are engaged in research and development of new technologies. Many of our resources are reinvested in the research and development department, and last but not least, all our products are covered by a 5-year warranty. GM International has always been perceptive to market demands. For this reason, its products are innovative in order to get maximum customer satisfaction. The strong point on which GM International bases its activity is the complete pre- and post-sales assistance in order to lead its customer to find the best solution for their application and to assist them in the correct use of the product. In addition, all our products are entirely designed and produced in our headquarters in Italy and are tested in a highly automated process. The following slides show how GM International is located around the world with over 200 people who makes up our staff distributed on all continents. We have product stock distributed in our main branches in Dubai, Singapore, India, Houston, and from this year also in Moscow. The last slide lists some of our main collaborators and customers distributed among system vendors, APC, on them, and end user. Well, I finished my presentation, and now I'm leaving Andrea time for his presentation on today's topic. Please, Andrea.
Thank you, Massimo. Sorry for this, but we want to introduce a little bit more company, where it starts from, and what product we use, of course, besides safety relays. So this is the first slide dedicated to the relays. So as you see, maybe you are aware about the PFD, probability of failure on demand, which is a really big part of SIL level. And so the PFD indicates the possibility that a device is not able to carry out the correct safety function. And so it's very, very important parameters. And of course, if you have a SIF, have a loop, all the parts belong to the group, that work in the group, has to have PFD available. So if, for instance, a loop where you have start from basically from the sensor, in this case you have barriers and so on. You have a logic solver, you have safety relays, you have and other parts, you have maybe electronic valve and so on. Every single part, of course, has to have this kind of parameter available. And it's really very important that each part, of course, must be suitable for the SIL you want to achieve in this loop. Okay. So just introducing the loop, and of course the SIL relays, of course, is a part of it.
Sorry, Andrea, try to adjust your audio because
yeah. Sorry for this problem, which I try to be more close to the computer, so maybe it's better. And thank you, Massimo. Now we have, I want to start with Paul. Please answer to these questions quickly. Just to give you an idea how to have them a better understanding of what kind of activity we have today. So what kind of relay you are using on your applications is very important for us. So that you are using lots. So the activity we have today are, of course, a mix of, let's say, system integrator or company are using both safety relay and non-safety relays. Okay, that's also very important. We'll leave you maybe another few seconds and we stop the voice. Okay, there is a mixed part that people that are using half part just marshalling couple relays and the other part safety relays. Okay, I stop it now. So, is it better now, the audio, Massimo?
Yes. Here.
Okay, thank you. Then we can. You can also always make a question by pushing your the right on the Q&A button. You see. Okay, so safety relay for any critical application. So, and when you need really safety relay, when you have a SIF, you already said that it must be conformed to the PLC 61508. So typical cases where you have, of course, and you want to stop or start in a safe manner motors, or you want to open or close a valve, and so on. That is the typical case for using a safety release. But it can be used, of course, and when the controller cannot meet the requirements. So when your controller is not able to carry out or probably drive a specific load, that is the application for safety relays. So basically, when you want to multiply the contacts, that is another application. So you have one contact out, you want to multiply it by 2 or 3. Or maybe when you want to invert the safety function, you want to close when you are opening and so on. So that is the application for safety relays. And also today I had to talk with the customer. They want to use safety relay not only for oil and gas, but the chemical industry where the application was power. So also is very, very important. And besides power, you can have railways, car, and lift, and any application where the failure of the safety function can cause a serious accident. So there are a lot of applications for safety relays. Here on the field side, you can see what is the sorry. I'm using 2 monitor and I want to close something. Perfect. So this is an application where you have a PLC output which is driving a load. And as we said, maybe the power requirement for the load is not cannot be supplied by the PLC directly, even if we're talking about safety PLCs. So it could be directly controlled load, but in case the power supply is not enough, you need the safety relay that will give you 5 amps or 10 amps maximum power out. That is the application. The PLC is driving a relay, which is driving a load. And so the application we already discussed is we are talking about process application. Can be cylinder valve for ESD and fire systems. Can be beacons or other signaling devices. We are talking about also BMS, the management system, also activation of load and motors for ADC and DC applications. If you want to make any question, please write on your Q&A button. Then we have other questions later, because during your registration, you made some questions and you wrote some questions, and we try to answer, we prepare ourselves, we try to answer to those questions by other slides. So for SIF, so a standard relay cannot be used in a SIF. So you can't use a standard relay which is not certified in SIF application. That is the most important thing we have to take into account. So because a SIL certified relay is a relay with a known and warranty ability to perform a given safety function. So you know what kind of safety is able to give the relay you are choosing. That is an important thing. Maybe also the relay you are using is very safe, but it's not proven, so it's not certified, so it cannot be used for that function. Okay. So safety function aim is to reach a specific safe state on the valve, open a valve or a fire extinguishing system. So that is a very simple question or function. So you basically is open or close or start and stop. No other things we are talking today for process application. Safety relays are able to comply that safety functions. So most of the time we are talking about ESD, PIPs or burden management system. The safety function is normal energized. So in case of safety, you want to de-energize to safety. So DTS. Basically, the load is energized. In case of safety, you want to open. The other way around, for fire and gas, the application is normally energized. You want to energize in case of safety. Those are the main functions we are talking today. So, energize to safety or de-energize to safety is the two components we already introduced to you. So, and in this case, we can have 4 different conditions because you can have the different position for the relays. Those are the 4 questions, and you can see also on the drawing on the right side. So basically here on the top you see the normal energized load and normal energized load. The normal energized load in the position relay is different. The connection relay is different from the normal energized load. But let's talk later about that. This is the application. So we have a condition. The first is a normal energized coil, a normal energized load. That is the condition. And in case of safety, this is the function you want to perform. So the coil will be de-energized, so the contact will be open. Always for normal energized, I can have the normal open contact. So in this case, the load will be off, and the safe state means I de-energized my coil and my contact will be closed. In the process application, there are a lot of these different conditions, different situations. So let's talk about normal de-energized coil. The coil in this case is closed, so my load is on. The safe state means that I energize my coil and I open my load. So in this case it is de-energized. So I can have also the other, the one on the right side, bottom right side, where I have the, to energize my load. There are different situations in the market. Let's make some example to you because I want to give you more details about that. So we're talking about coil non-energized and normal energized load. So this condition can be reached by using just one relay. So the SIL2 can be reached by just one relay. That is the norm for non-energized loads. And easily I can reach the SIL3 condition by using 2 relays in series. That is the application for normal energized. While if I have a normal de-energized load, 1 relay is enough just for SIL1 application. So if I want to reach a SIL2, I have to use the second relays connected not in series like for non-energized, but in parallel in this case. Okay. And the SIL3 I can reach by using 3 relays in parallel. That is, those are simple things, understanding, but we are talking about safety, and but a very important thing is also the availability. And availability is important because you don't want to incur in, let's say, unwanted spurious failure. What is important indeed? Important is that in this case, one relay, I have here, remember this was a configuration for SIL3, for safety, for non-energized load, but the availability that I reach by using this kind of configuration is low because one relay fails, and I have to say, I put in a spurious state. So it means that I de-energize my load without any real safety situation, and I stop my plant because one relay of the connect is will include in the failure. So high safety but low availability. Also, this configuration for normal de-energize, which is SIL3 for safety, is low, let's say, has got low availability because one relay can, of course, activate the load in this case because of failure. And I reach really an unwanted non-safety situation where I activate my load without any real dangerous situation. So safety means sometimes the opposite of availability. But I'm pretty sure that on your own application, also customer asking for the availability, they don't want to stop the system because of failure or spurious failures. So here there is another architecture that, I would say, example of that. So we are talking about safety and availability. And here we have different configuration for non-energized load, which is the most important and most important from our customers. Here I have a configuration 1 out of 1 for non-energized. I have 1 out of 2. I have 2 out of 2. That is not good, of course. And 2 out of 3. We are making all examples so you can understand better. So we're talking about dangerous failure and safe failure. Safe failure means availability, and dangerous failure means safety. Okay. So in architecture 1 out of 1, here I can reach and mean time to failure, and the TTF, pretty sure that you know this acronym, is about 25 years. So my system is safe for 25 years. Safe failure possibility. While is dangerous failure is 50 years. That's a big parameter. If I'm using 1 out of 2 configuration, so the 2 relays in series here, I increase a lot my safety because it's increased by 50 times, but I decrease a lot my availability because I reduce by twice the availability. Increase the safety, but I decrease the availability, which is good for safety, but not good for availability, because maybe it's also that critical point. It's not nice when your customer are calling you because you got one failure on your system. If I'm using the architecture 2 out of 2, here I increase a lot the availability, very good, but I decrease a lot of safety. So this is not a good configuration for normal energized. If I'm using 2 out of 3, so I have the voting system, so 2 relays have to say the same things to perform the function, to be okay. Here I say respect to the one out or two increase a lot of availability, but my safety is not as good as in configuration. Pushing the wrong button. Sorry. In this case, is not good for safety as it was in architecture 1 or 2. So I introduce another point in our relays. We decide to use architecture 2 out of 4, and you will see why. That's a very, very important point. So I already introduced the next poll. I want to ask you to answer. So if you can take your time. So we are talking about availability and safety. We want to ask you what is the most important part for you. If there is a better safety or better availability, or what you want to ask if you need multiple contact relays and so on. Thank you for voting. A few seconds, and then we'll stop. Okay, I can stop now. That's a surprise a lot to me, because high availability is much more important than safety. We're talking about safety, but we understand that that is a critical point. So we can go to the next slides and discuss about this. So this is the configuration that we realized. So it's a 2 out of 4 configuration where we have 2 relays in parallel, and we can see this load and the 2 relays in parallel. So let's see what happens for normal energized. Normal energized means that I have to open my relays. So the coil is activating all the relays. And if you can see here, one relay is stuck, is not opening, but that is not sufficient for dangerous failures. Okay. So that means that my safety function is assured also if one relay is got failed. So also for normal de-energized, the next one, all relays closed, but one not, because it's failing. And that is not enough for dangerous failures, because the circuit here is closed by the aluminum connector. So this is a configuration that improves safety. So is able to perform even if one relay is having some problem. So let's see what. But we have talked, we've seen that is also important for you, the availability. And the availability here means that my relay is not having problem. I'm not asking to open the contacts because the system is working properly. But I see that one relay is having failure. But that is not sufficient to de-energize the load. Okay. So I'm not losing my safety function. Not losing availability in this case, okay, because one relay is failing. Okay, so this configuration for normal energy is very safe, you've seen in the previous slide, but it's also available. Okay. Also for normal energized, if one is, I don't want to close my contact, but one is closed for any reasons, that is not enough because the circuit is open on the two relays on board. So this kind of architecture is good for normal energized and for normal energized, for both applications. Then we introduce another point. So we have seen that one relay inside can fail for any reasons. But then basically I wanted to be, let's say, detect this kind of failures. Then why we wanted to be, why is important to choose a relay with built-in diagnostic also. There are a few points. So all diagnostic digital output systems do not support, sorry, all system digital output card do not support the diagnostic. So they just close in contact and open contact. They do not know what happens on the load part. Okay. All systems are DO system are voltage and current limited, so they are not able to power the load. Or maybe the DO diagnostic limits some extreme load leakage. They cannot detect those kind of failure. Smart relay with diagnostic can make the diagnostic available to the system, can report to the system the failure inside the relay or the load. And the smart relay extended your diagnostic capabilities. And also the relay with the built-in diagnostic can report any kind of fault, both for non-energized or normal de-energized applications. So for the moment we have finished. This is just, of course, the part dedicated to the presentation. But now we have the question and answer from you, not from you. You register yourself, so we want to answer you. So switch immediately to the new one. In the meantime, if you have any questions, just tell us what you have.
Well, Andrea, we can open the second part of our meeting. I remind our participants that they can ask their question through the Zoom question and answer function. In the second part of our meeting, we show what are the typical questions which are most frequently asked on their relay topic. For example, the first one is, can the safety relay be stored in a hazardous area? But Andrea, I don't see a slide.
Okay.
Okay. Thank you. Well, yes, it's possible to install a device such as a safety relay in the hazardous area, placing it in a special enclosure certified for the installation area. Or, as shown in the slide, in more cases, there are safety relays certified for installation in Zone 2. This allows us to install the relay as close as possible to the load with great advantage in safe cable. This means save cost. The other question usually is related to the pulse testing compatibility. And what is it? Well, almost all PLC DCS systems have the possibility through a series of pulses to test the status of the line that connects them to the relay coils. Compatibility with this pulse test range is very important in a safety relay. First of all, to allow the correct test of the line, and moreover to avoid this, that these pulses causes the chattering effect in the relay, or to avoid the spurious activation or deactivation of the load, as well as damage of the relay itself. This functionality is fundamental, especially in fire and gas application, where it's important to know the health status of the line as at the time of the request for intervention, we must be sure that everything will work correctly. Another question.
One more thing, Massimo.
Yes.
Systems where the pass testing cannot be deactivated. So it's important to know that, because if you cannot deactivate it, and you can incur when you are using some type of safety relays that your load will be activated continuously, because the relay is not able to say, to absorb this kind of, it's not compatible with the pass testing. So it's very important we are choosing safety relays from GMI, from other manufacturers, that you have to check this kind of features. So the relay must be compatible with the pass testing.
Yes, it's fundamental.
Okay.
Okay, thank you, Andrea. Another question, is there any solution offering multiple contact output? Well, there are solutions that provide for multiple output contact controlled by a single input. These multiple outputs allow us to have multiple loads connected and driving simultaneously. An example is in the slide is the D5290 S078. This allows us to drive at least 2 SIL loads with only one relay. In fact, this type of relay allows us to have application in which we can simultaneously drive 2 normally energized SIL3 loads, or up to 4 SIL2 loads, always normally energized, or even 2 normal de-energized SIL3 loads. Of course, the possibility of having different loads driven by a single relay allows us a considerable saving in terms of space, as in only 22 millimeters, we have the ability to control different applications. Well, another question typical is regarding 1 unipolar and or 2 bipolar wires load. Well, the safety relay can be connected in unipolar or bipolar configuration, but what is the mainly difference between the 2 solutions? A bipolar connection allows us to completely isolate the load, and this is recommended, especially in application where the load must be powered with high voltage. From an electrical point of view, this type of connection gives us greater safety thanks to the complete isolation of the load. In unipolar solution, and connection isolates the load only on one of the power supply lines, and allow us to bring a negative to earth in case of need. Furthermore, this type of connection allows us a great benefits from the point of view of cable savings. This is the main characteristic of the 2 connections.
Okay.
Well, how choosing a relay? Well, the choice of the correct safety relay must be made taking into consideration various factors, such as compatibility with PLC pulse test system, the type of coil power supply, the safety function that it must perform. In this regard, it's important to say that the choice of the relay is fundamental relative to the type of load and the safety function it must perform. In fact, it would be very harmful to choose a relay that performs a safety function different from the one required by the application we have to create. Suppose, for example, to choose a relay suitable for normally energized loads to drive and fire and gas system. This would greatly increase the risk for our system, as using a wrong relay in its safety function increases the chances of failure in case of relay intervention request. Therefore, it's important to choose the relay correctly based on the safety function it will have to perform. Furthermore, let's not forget that the choice must also be made, bearing in mind the need for a diagnostic capabilities on the part of our relay, the need for single contacts or multiple contacts, and finally the contact rate of the relay. Even in the later case, the choice is important, as choosing an incorrect contact rating can have serious consequences for the state of health of the relay and therefore of the entire application. Well, another question regarding the fault mirroring. Can the fault for a monitor relay be mirrored directly to the PLC DO? Well, yes. There are relays that when they detect the fault in the field, can, through a variation of the dynamic impedance of its input, send a fault signal to the most model supervised PLC DCS system. This function allows us to reflect information relating to the field fault directly to the supervised DO card of the PLC. This functionality is available both in the off state through the pulse test system and in on state by reading the static electrical current. The DO card of a PLC system can detect the information relating to the field fault. This system, through an upward impedance variation of the relay input circuit, allows us to supervise to see the fault in the field. This system allows considerable savings in the engineering cost, as it allows us not to use a dedicated D card for this purpose. Well, another question, can the fault be interfaces with field bus? Well, there are particular safety relay models called smart relay, which can provide complete diagnostic information through Modbus multi-drop RS485 protocol, if a Modbus master is available on the system side. Up to 100-270 modules can be arranged in a multi-drop network and monitored, configured by a single master unit, as shown in the following picture. Through an address and when requested, makes available its value for reading writing. What are the advantages of using Modbus communication? Well, with a single Modbus RS485 interface, it's possible to connect and communicate with all the relays present on the same bus. Multi-drop connection is possible, and communication can cover a distance of up to 1,200 meters. Another advantage is the possibility of not using a dedicated digital input system to monitor alarms. This allows us to have significant savings in terms of cost, real-time information on the type of alarm and on the health of the load and the line, It's also possible to Modbus a complete remote programming of the relay. Well, Andrea, I leave you.
Yeah, another point, Marcel, because about the Modbus communication, that you can discriminate the type of fault you have on the outside. So while there are certificates that give you contacts out, that give you contact out just general information about.
Sorry, Andrea, your voice is unclear.
I want to say that basically, but now?
Now, okay.
It's basically this contact out for fault is give you just an information about a generic fault. You cannot know what kind of fault you are having. While Modbus, the different registers give you exactly the information about the fault. That could be open circuit or short circuit, or also fault, the coil, in this case for the valve, the internal relay fault. So there are different possibilities with the Modbus communication. Okay, let's, I continue. I have another question to answer. So, yeah, there is one person that asking, please repeat the advantage of using Modbus. So I can repeat. Modbus, basically, if you have different relays connected in one application, you can use just one Modbus port on your DCS or PLCs that is able to acquire all different relays connected with. And so you don't need a single digital input for any relay connected. One Modbus port can read all relays connected. The other advantage is you can have a very long communication distance up to 1,200 meters. The third advantage, which is maybe the most important, you can, let's say, have the exact information about the fault you are having. So Modbus is able to read the exact register of the fault. It can be open circuit, short circuit, it can be water leakage, coil, the valve fault, internal relay fault, and that's all. So but you have exactly information about the fault. Hopefully also to express otherwise.
Another advantage is the complete programming or monitoring of the status of the all relays placed on the bus from a remote PC.
Other question, a SIL relay can be used in a SIL2 application. That is, we are having a lot of this question from attendees. We prepare something. So just to remind you, so the SIL level can be 1, 2, 3, 4. 4 is the most available. People don't ask for 4, of course. SIL3 is the topic, is the best SIL asked. Definitely, SIL3 relay can be used as a SIL2 application, but not the other way around. So if you are, if the SIL3 level for your loop is the one asking, you cannot use a relay which is SIL2. That's not possible. The other way around is possible. Let's look at this example. So we are having an application where you have SIL3, can be any other devices. You start today, and by the time you are, let's say, by the time you're using the hardware, the relay won't be certified anymore for SIL3, but it will become SIL2. And if you are using the time, you can have also right to a SIL1. What you have to do in this case, you have to test the device and to restore to the initial condition. Every single producer, manufacturer, to give you a SIL certified device, must give you also a SIL manual where there is a testing proof instruction. So explain how to test a device after a certain period. And
we have a question from our attendee.
Yeah.
That asked us, what is the PFD?
PFD, okay, let's, PFD here also is mentioned also is a probability of failure on demand. So, but there is a demand, you want to open or move a contact, that is a probability of failure that that device will not perform that function. So, it's, of course, probability of failure is the better is the lower, of course, possible, the lowest possible for application. And in this case, we were talking about the testing proof that is very important to restore the initial condition. Let's say that, coming back to initial question, can I use a SIL3 relay in a SIL2 application? Yes, because the thing is that here I can have a SIL3 relay that is available for 1 year, but could become a SIL2 for 10 years. So I can use the same relays, and in our manuals we write clearly that you can have the safety, the SIL2 lever that is available for number of years that is higher than the number here that could have for SIL3 application. Hope we answered this question. So the other point was design aspects. Of course, this is industrial secrets for GMI, so there are a lot of patents in our relays, but we can give you some details about that. So also we have seen that we are using 4 relays, most of our relays inside to, let's say, to define safety function. But also this kind of architecture can be used also in the components, can be also redundant inside. And that is also another point. You have to consider also beta factor. And the beta factor means that if you're using 2 components in a redundant system, and those components can fail at the same time when, if they are made by the same manufacturer, which is the same product, which is has been produced in the same time. So there is a very high probability of failure that those devices or those components could fail at the same time. So the beta factor reduces a lot the safety of your application. This is must be considered also, of course, inside the components, not only for the 4 relays we see in different in our architecture. So, and also architecture can affect the availability and the safety of the system. Other point is the failure rate. So the failure rate for the components. The components inside, of course, must be have failure rate declared by the manufacturer. So better components means better results. Also, the characteristic of the components inside, like gold-plated relays, silver relay, force contact, multiple contact, are very important features for the product you want to be claimed for sale. And the last, of course, is the F-meta analysis. So the F-meta analysis that give you details like PFD, probability of demand, the MTBF, mean time between failures. And F-meta analysis is a result for relays, is a result of the analysis of all the components inside. All the components must have F-meta values, F-meta calculation supplied by our supplier. So that is not, you cannot use any single components you find in the market, but if you want to have a SIL-rated product or SIL-rated relays, like in this case, the components must be, of course, safe. Okay, so let's go to another question, which was why gold-plated contacts are important. So gold-plated contacts are really very important because we are talking when you are talking about low power load, so you're talking the current load of 100 milliamps. So those little currents can cause oxidation and spurious too, of course. We cannot say the relay can stuck. And so the relays that we are using inside, which was, as you remember on the previous slide, is really a safety function, safety, let's say, extra characteristic we are asking, can grant very high reliability also for small current, let's say around 1 milliamps. Okay, so the other question was coil voltages and the relay load currents. We can offer this kind of coils, can be 20, so output contact from your PLCs or DCS can be 24 volt, 48 for some cases, 110 VDC, 150 VAC, 230 VAC. Different single contact or multiple contacts for normal open or normal closed. And the relay contacts can be 3, 5, or 10 amps. That is the relay classification. So also another point was SIL3 relay with the SIL2 diagnostic. How is it possible? We have talked now earlier. Remember that there were applications where if you want to claim a certain level SIL for your loop, and this must be SIL3, all the components in the loop must have SIL3 certification. But inside here we have, for instance, nowadays we have SIL2 diagnostic because it's a software based, and the software is very difficult to reach in over this SIL2. In this case, I can have my safety functions and diagnostic function. Two different, and they are not interfering each other. So the failure for the diagnosis is not interfering with the safety function, which is different. That is the secret, let's say, the way how the relays are certified for SIL3, even if the diagnostic is SIL2. Okay, the last question, and is process and machine safety relays. There are a lot of differences you cannot use for the same application. And process and machine safety. Process application requires safety integrity level, SIL certification. So we're talking about valves control, horns, lights, sounders, beacons. Really safety. There is no manual control. It's not permitted, not interfere with the safety function. When your DCS is closing contact, or safety concealed matter, the relay must switch immediately without any delay, without any manual control. That is not permitted in the certification. While for machine applications, there is a performance level certification, which is a little bit different. We're talking about safety gates, light barriers, speed standstill, different application. And there is a really manual control. The classic red mushrooms you find on in the factories, they go to basically to an input for safety relay for machine application here. And there is a different control, different system, which is not, and here there is really manual control because also the knowledge for the relays is permitted. So are two different words and cannot be mixed with each other. So I think we finished for our presentation today, Massimo. I don't see further questions. Please right now, otherwise we'll stop in a moment. I want to remind you that we, in our website, you can participate and register your sheet for the next webinars. We have a lot also for this September, it's last part of September, October, November, December, other topic. And please look at our website. You can also, let's say, review this webinar and the others because are all on our YouTube channel available. And I want to ask you if you want to just rate our webinar. Thank you very much. And with this, we finish. Thank you very much again. We hope we answer to all your questions. Otherwise, we will remind you the next slide our contacts. You can write us or phone us as you prefer. We are always available. I stop. Thank you very much for participating.
Thank you, Andrea. Thank you to all our attendees.
Yes. I remind you our contacts here, our details. And with this slide, we close and hope to see you soon. Thank you very much.
Thank you.